Just going through, when we're talking about the history of bridges, some of the more common or the more renowned failures of civil structures, some of which unfortunately did result in loss of life. So I'm going to be completely respectful when I'm talking through this. The first one was in 1870s. Once again, I have not opened up a history book to get the exact date. But about there, this is across the Firth of Forth in Scotland. Winds coming in off the North Sea, incredibly cold, incredibly cold, and in gale force, 90 kilometres an hour, 100 kilometres an hour. Our family live in the very north of Scotland, and I will absolutely guarantee you don't want to be standing next to the North Sea in a gale. It's like -1, -2 degrees before the wind hits. It's cold. So the Tay Bridge is there. They're travelling a train across a bridge in a gale. Once again, before civil engineers understood, they built the piers, they put the bridge on top. They didn't tie it down because the bridge was heavy enough, so it wasn't going to go anywhere. Until you go and you put a train across that vibrates the bridge and bounces the bridge in a gale. And it literally blew the bridge into the ocean with the train on it. Massive loss of life. And they lost about a third of the bridge, just blew in the ocean. Come back later on, the big lesson they learned out of it is you need to tie bridges to piers. The replacement bridge still stands today. Tacoma Narrows Bridge. Bridges cost a lot of money to build. The more material you use, the less the force in every member of the truss from when we talk about truss analysis. So the thicker the members of the truss, the lower the strength and the less likely it is to fail under tension. Unfortunately, it weighs more and it costs more. Tacoma Narrows was built in 1930 in the middle of the Great Depression. So 1935, I think it was. Designed and built in the Depression as a project to give people employment. Because they're running out of money, it was built as lightly as possible. That light, it was a suspension bridge, so there's two towers with a cable. That's anchored in the ground, that's anchored in the ground. It's an incredibly lightweight bridge. Looking at it in cross section, to make it cheap, it was a square, a box section. Designed to withstand a gale, but in a breeze of 25 kilometres an hour, it started vibrating like a guitar string. And literally, please Google them, hundreds of videos on YouTube. Vibrated like a guitar string, hit what they call the natural resonant frequency, and it just vibrated itself to pieces. I think probably every single engineering class in the entire state's seen that video.
Mm-hmm.
So, what did they learn out of it? To make bridge designs like an upside down airfoil. There's the deck, there's the airfoil. So now the harder the wind blows, the more the downward force on the bridge to keep it stiff. But never ever crossed anybody's mind. You don't learn about things until something happens half the time.